In this last section of Unit 13, we're going to go ahead and take a look at power. And power is simply the rate at which work is done. Since work is the transfer of energy, it's also the rate at which energy is consumed. If you've ever looked at a light bulb, you know it has a watt rating, and that watt rating is telling you how well or how quickly it changes electrical energy into light energy. Now, the idea of power was developed by a guy named James Watt in the late 1700s. He was an engineer and scientist who actually did a heck of a lot of work on steam engines. He didn't invent the steam engine. What he did was he improved the steam engine. He put a condensing unit outside the steam engine so that the steam was actually doing work on the piston instead of heating the piston up and cooling it back down. So he greatly improved the efficiency of the steam engine. And by doing so, he made it desirable for people in the mining business. They already had some engines, but they wanted more. They had horses that were designated to pull water up out of the mines and do a lot of work. And they were interested in his engine, but they wanted to know how much work his engine could do. So Watt measured how much work a horse could do in a certain amount of time and compared that to the amount of work his engine could do in the same amount of time. And so he would say, hey, my engine can do the work of 4 horses or 8 horses or 10 horses, whatever it was. And so what he did was he effectively developed the horsepower. He could tell you the rate at which his engine could do work compared to the rate at which a horse could do work. Because he did so much work with this, the SI system uses the watt to designate power. It is the SI unit of power. 1 watt is 1 joule per second, the rate at which work is done, so work divided by time is a watt. A watt is fairly small compared to a horsepower. It takes 746 watts to equal 1 horsepower. Now there is an equation for power. Because power is the rate at which work is done, we can calculate it, and it has a very straightforward equation. Power is equal to work divided by time. Now remember, work, like energy, is measured in joules, so that means a watt is equal to a joule divided by a second, or a watt is a joule per second. Okay? So we're going to use that to actually go ahead and work a practice problem. And I'm going to start with a fairly complex practice problem because I want you guys to get used to pulling out information and having to solve for things using multiple equations, multiple steps. You need to be able to break a big problem down into smaller problems. So make sure you're paying attention to this. A 1,000 kilogram car accelerates from rest to 30 meters per second in 6 seconds. How much power did the engine generate? This is not a straightforward problem. It's got a lot of information and it's not going to be able to be done in one step. So the first thing to do is always go through and find your information. Right here I get some information. That's a mass. So M equals 1,000 kilograms. From rest, it says the car accelerates from rest to 30 meters per second. This is a velocity. Okay, and this is also a velocity. When you see that it accelerates from something to something, that means you have an initial velocity and a final velocity. So my initial velocity is rest, which is 0 meters per second. My final velocity is 30 meters per second. So you'll notice I haven't decided what equation I'm going to use because I don't know what equation to use yet. I'm still trying to figure out what information I have. In 6 seconds, so there's some more time or more information. The time is 6 seconds. And then finally we actually get to the question, how much power did the engine generate? So the last thing I'm going to write here is power. What do I want power. Well, I only know one equation for power. I'm going to write it down because it's going to tell me what to do next. Power is equal to work divided by time. I have time. It's right here. So if I knew the work, then I could put in the work and find the power. But I don't know the work. Now, there's some other things I could do to try to find work. I knew the equation that work equals force times distance. I don't have a force, so I don't know that. I might be able to find the force, and I also need distance. I don't know the distance. So this equation probably isn't the best one to use. If there's another equation I know that involves work, that might be better. And there is another equation I know that involves work. Remember, work equals change in energy. Well, I can figure out how much energy this car gained because we know it started at rest, which is zero kinetic energy, and ended at 30 meters per second. So what I'm going to do is I'm going to find the kinetic energy of the car. KE equals 1/2 mass times velocity squared. So this equals 1/2 times 1,000 times 30 squared. You'll notice I'm not doing the zero part because I know it started at zero kinetic energy. So I'm just finding the final kinetic energy. So this equals 500 times 900. 30 squared is 900. 5 times 9 is 45, and then I have 4 zeros after that. So 450,000 joules. So I know the engine had to do 450,000 joules of work to accelerate the car because it ended up with the car having 450,000 joules of kinetic energy. So now I can actually find the power. So work 450,000 divided by time, 6 seconds, will actually get me the power rating of this thing. So this is joules divided by seconds, and 450,000 divided by 6 is 75,000 watts. So quite a few actually, about 100 horsepower give or take, 75,000 watts of power in order for this car to accelerate from 0 to 60 meters per second or 30 meters per second in 6 seconds. So this is a problem that took a few steps because you were not presented with work and distance and time. You had to actually figure some of that stuff out. That's all right. Let's do one more example problem that is maybe just a little bit simpler. We'll see how much power do you generate in lifting a 60 kilogram mass in 2 seconds. So how much power do you generate in lifting a 60 kilogram mass 2 meters in 2 seconds? Well, again, I'm looking for power and I'm given some information. I know the mass is 60 kilograms. I know the change in position or the height of this thing is 2 meters. I know the time is 2 seconds, and I know I want power. Whoops. So power equals work divided by time. So I want to find work. Again, I don't know force, I don't know distance, I don't know work. But I do know I'm lifting something, which means it's gaining potential energy. So I can find the work it takes to lift something because I can say that the change in energy is equal to the work done. So I'm going to say the work is equal to mgh. Yes, that's potential energy, but that's force times distance. Okay, right? Mg is weight, which is force, times h, which is a distance. So here I have 60 times 2 times 9.8. And 60 times 2 times 9.8 is 1,176. This is joules. Now that I know how much work it takes, I can divide by time to find power. So power equals 1176 divided by 2, which is 588 watts. So less than a horsepower, but still quite a bit of power for a human to generate.